All right, look what I've got. So first of all, I need to thank a very, very generous viewer who sent me this thing. So thank you, John. I don't know where he got it, but he said he wasn't using it, and if I could use it, he would send it my way, and here it is. It looks like a really, really old Keithley, and it is. It's vintage Keithley. Keithley is very well known for its ultra-low current measurements and stuff like that. So what is this box? This box is a Keithley 619 electrometer / multimeter. So what's the difference between an electrometer and a multimeter? It has a volts measurement, amps measurement, and ohms measurement. So it is a multimeter, measures different things. And right now we're measuring a 1K resistor, so it's measuring 0.99976, anyway, kilo ohms. So 1K. And so what's so special about an electrometer? It's the input impedance. We'll take a look at the specs later, but it has very, very high input impedance. And it ends up being basically a high input impedance 5.5 digit voltmeter. It's a little fancier than that, but that's basically what it is. So what am I doing here? So I have my my decade box on top, so we're measuring resistance, and I have it set to 1K. So we can go up. I can go to 10K. I can go up to 100K, and we can go to 1 megohm. Let's see here, 1 megohm. So there's 1 megohm. Now, it actually can do a lot more than that. So let's take a look at the front panel a little bit, and then we'll go take a look at the data sheet. It has the ability to have 2 channels. It only has one channel. It was an option. You had to buy a second card that goes in it. So this one only has channel A in it. If you hit channel B, it says no channel B. You can do the ratio of A and B and the difference of A and B. It has a zero checking in the, you can zero offset things. And you can set the speed at which it reads. So you can turn on resolution. You can go to a lower resolution, and it's updating faster. And then a slow resolution, it's putting in a filter, and then you can add a filter. So now it's going slower with a filter applied, and it figures out what filter is necessary for the type of measurement you're doing. It has auto ranging or manual ranging, so you can go down. I've gone too far. You can go down in ranges. Oops. Let me press this to get back here. So up range there. There we go. So we can change the ranging on it and go back to auto ranging. And it's IEEE 488 HPIB, GPIB, whatever you want to call it, controlled. So it's meant to be a system unit as well. All right, let's take a look at the data sheet, because that's one of the most interesting parts about this whole thing. The Electrometer 619. So it has voltage ranges. It has 200 millivolts, 2 millivolts, 20 millivolts, and 200 volts. So you say, okay, well that's not very exciting. Those are pretty generic voltage ranges. But here's the big but. The input resistance. So you get one of these multimeters. 10 megohm input. Some fancy ones are higher in maybe 100 megohm input impedance or something like that. Maybe even better than that. Maybe 30 megohm resistance or things. This one has input resistance greater than or equal to 20 tera ohms. Yes, tera ohms. That's pretty high. So that's the real difference between an electrometer and a multimeter, is the input impedance. It's just super, super, super high input impedance. So if you want to measure the voltage on a capacitor without modifying anything, right, without adding any drain to the capacitor, well, I'm going to think of a bunch of experiments to do. If people have ideas on what experiments they'd like me to do with this thing, let me know, because there's a bunch of them. But you could have a charged capacitor and you can come in and measure it and you're not going to touch it at all, 20 tera ohms. And it's not going to bleed very far. So yeah, that's the big deal, this 20 tera ohms. It's got great noise rejection and stuff. Here's amps. So the ranges of amps is much larger. All right, so I can read these. Maybe that's all I can zoom in. So it's got the top range is 2 amps. So even this thing has 20 tera ohms input. It also has the ability to do 2 amps current measurement, but it keeps going down. So 2 amps, 20 milliamps, 2 milliamps, 200 nanoamps, 2 nanoamps, 2 nanoamps with 5-digit resolution. So 1.9999 nanoamps, which means that picoamps, it'll do, let's see here, how many, that's 2,000 picoamps. Okay, so it'll do femtoamps, right? It'll measure femtoamps. Yeah, so it's getting very small in the amps range. Now, my favorite thing to do is measure resistance with this thing. Here's the ohms chart. Okay, so 2 kilo ohms full scale. Boring. 20K, 2 meg, 20 meg, 200 meg. Oh, we're getting good now. 2 gig ohm. Nice. 2 gig. Remember, this is 2 gig ohms full scale. Oh, wait a minute. 20 gig ohms. Oh, 200 gig ohms. Whoop, wait. 2 tera ohms. So full scale, direct measurement, 2 tera ohms. Wow. 2 tera ohms. I'm looking forward to that. So I've ordered some resistors to measure. I've ordered a 100 gig ohm resistor and a 10 gig ohm resistor, so we can try this thing out. Yeah, those aren't cheap resistors. So anyway, and then the rest of it's just, it's 5.5 digits, certain speeds, certain filtering, stuff like that, the IEEE 488 interface and stuff like that, picture of it. Okay, so that's pretty cool. The other document that I have, that I've had in my possession since the 1980s, is this book. And I think Keithley gave this book to you if you requested it. It says $4.95 in it, but I think if you ask Keithley, they'd send it to you, especially if you work for a nice company. And so I'm pretty sure I got this book for free, but it tells a lot about low-level measuring. What does it take to measure, picoamps, femtoamps, attoamps? What does it take, and what does that mean? And when do you get into trouble with physics, right? The theoretical limit by Johnson noise and stuff like that. What is actually doable and what is not doable? So here's a nice picture of this is what a digital multimeter can do. This is what an electrometer can do. And so, the DMM is bottoming out here, around a mega ohm or something, and then the electrometer is going up here to 10 to the 15th ohms, right? 10 to the 15th ohms. That's just nuts. Anyway, yeah, electrometers. Let's see here. Then it talks about, how are these measurements made and what type of errors do you get? How do you do shielding? Shielding is super important with these things, and so you can't hook a BNC up to these things. You'll pick up noise. If I just went over and touched my hand on the cable, it would change the reading. So you have to have. Not only do you have to have shielded stuff, but you have to have shielded stuff. So they use what are called triaxes, and so it's a coax with a shield around it. So it's a shielded coax. So it's 3 conductors. So there's a inner conductor, a shield, and then a shielded ground, a guarded shield. And a lot of times the guards are driven. So yeah, lots of fancy stuff in this book. So it's great. I'm going to have to read through this book again and see it, maybe have some ideas of how to do some low-level measurements and stuff. And then in the back, it actually talks about all the stuff that that Keithley made, all the cool instruments that Keithley made. Yeah, 614 electrometer, 616. They made lots of electrometers. 617. Here's my 619. 642s. And they had the old analog ones, very cool. I've seen those in use before. Here's a picoamp meter. Yeah, so anyway, lots of stuff, lots of cool stuff that that Keithley built. Keithley is, like I said, the premier company. And we can maybe use this instrument to see how my other Keithley instruments. I have 3 Keithley instruments now. I have the Electrometer, I have a 2015 Multimeter, and I have a 2400 source meter. So yeah, I think we can get in a lot of trouble with this thing. So I need to build a shielded box. In order for you to make any measurements, it has to be, like I said, a coax inside of a guard, and then you have to make the measurements inside of a shielded box. And so I've started working on it already. I showed a bunch of these attenuators. I got a whole bunch of them for basically free. And a couple of them that were just too busted. So I'm going to turn this one into a shielded measurement box. I'm going to put connectors on this and stuff, and it has this nice lid that goes on top, and I'll be able to put some triax connectors on it and stuff, and use this as my Faraday cage to do measurements. I think it's a good size and heft for the job, and you know, homage to Hewlett Packard. So I don't have a Keithley box, but they just sell them. Keithley actually sold boxes just for this. You could buy the shielded box from them, yeah, but it's easier just to build your own. So that's what we'll do. And then when I get those resistors in, we can start measuring them inside of here. Let's see if that thing really works. Also, when we got around to seeing how accurate this thing is, it may need calibration. I mean, it's quite old, and it may need calibration. And there is a calibration routine online. I have the service manual for this thing, and I believe I do have enough instruments to calibrate it, but I haven't committed to doing that yet. I think a lot of the measurements are just kind of fun, not absolute measurements, but relative measurements. You know, how does the voltage change on a capacitor? How does the current change on a capacitor? And we'll be able to measure those things. And they're just delta measurements. We don't need to have them accurate. We need to have them relatively accurate. So if that makes sense. So anyway, there you go. New toy of the day, and I'm looking forward to playing with it. And thanks again to my viewer. Very, very generous. And it will be in good hands and a good home.